We're on the 7-7 green worksheet, number 2A, a quadratic function whose graph has a vertex at 3, -8. Let's go ahead and sketch that on a grid. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. It's really a great problem to review not only the concepts of polynomials, which we're doing right now, but back earlier in the chapter when we talked about quadratics. So they tell us that that vertex is a minimum. Now with a vertex automatically comes what's called a line of symmetry. So keep in mind, as they tell you that they only give you one x-intercept of 5, are they really only giving us one x-intercept? Because if 1 is here at 5, and this is our line of symmetry at 3, where do you think the other intercept's going to be? If you guessed that number, you're correct. There's one at 1 as well. So we know that the parabola has x-intercepts at 1 and 5. They tried to be sneaky there and only give us one of them, but we can use our some intuition there and think of what the other one must be. So we know that y equals a is the dilation, times x minus root 1, which would be x minus 1, and x minus root 2, which would be 5. So at this point, we don't know the a, but we do know the vertex. Well, the vertex is 3, -8. Let's use that as our point to plug in. -8 will replace y, a is unknown, and 3 will replace the x. So what we know is -8 equals a times 2 times -2. 2 times -2 is -4. A equals -8. Divide by -4, a must be 2. So this parabola is dilated by a factor of 2, and it's right side up. So the equation is y equals 2 times x minus 1 times x minus 5. Okay, I cleared all that off there. Now we have the proof of, not the proof, I was just helping someone with geometry. The fourth degree polynomial with two double roots, 0 and 2, and whose graph contains the point 1 and 1 comma -1. Let's go ahead, let's do this one in red. 1 comma -1 is a point on the graph. It's got two double roots, one at 0 and one at 2. Okay, one at 0 and one at 2. One at 0 and one at 2. Okay, so if this graph has double roots, a double root here, it has to open down, come and hit this point, and somehow go back and hit again. I'm thinking that the graph would look something like this. It's a fourth degree function, and it looks like it opens downward. I can't think of another way that it would have double roots at 0 and 2 and hit this point down below the axis. So it has to look something like that. So when we go to build this equation, we're going to have the missing a. We're going to have a double root at 0, and that's going to be squared because it's a double. And another one at 2, and that's going to be squared because it's a double. Let's eliminate the minus 0 and just make it x squared and x minus 2 squared. Let's take the point that they gave us, 1, -1, and use that to plug in. -1 is y, 1 is x. Let's solve for a. -1 equals 1 squared is 1, so it's irrelevant in this problem. -1 squared is 1, so it's irrelevant in the problem as well. And look what we have. A equals -1. So the solution here, the polynomial would be -1 is a times x squared times x minus 2 squared. If you take both of the answers from number 2 here and graph them on your calculator just to double check that it produces graphs with the given features, then we're all set. Any questions? Let me know before Friday's test.